So under those four assumptions, linear and parameters, IID or random sampling, no perfect multicollinearity, and the expectation of U given all the x's equals 0, the error term is mean independent of all the independent variables, we get unbiased estimators for all of our beta hats. So let's look at two different things that could happen. Maybe we add too many variables into our regression. We include variables that are kind of irrelevant to our analysis. We'll look at that first, then we'll look at what happens if we leave something out. So let's first talk about that first situation, including relevant variables. So we usually call this overspecifying the model. Overspecifying the model. Or overspecification, I guess would be the other way of saying that. And this is what happens when you include variables in the regression that have no partial effect on y. So they don't really matter for a y, but we put them in by mistake, or we thought they might, and so we threw them in the regression. No partial effect on y. So let's look at an example. So let's say we have y equals beta 0 plus beta 1 x1, how many do we have here? 3. Plus beta 2 x2 plus beta 3 x3 plus u. And let's assume our assumptions 1 to 4 are satisfied. So we're going to assume those assumptions are satisfied. And we're going to assume that, so the other assumption is going to be that x3 has no effect on y once x1 and x2 are controlled for. So essentially what we're saying is x3 is this variable that's causing an overspecification in our model. So we really didn't need to include this variable. It doesn't affect y once we've accounted for these other two, but we included it. So what happens? So let's rewrite that regression again, just so we have it on this board to talk about. So we had 3 independent variables, but this x3 kind of was that overspecified, the variable that caused this overspecification. x3 has no effect on y once we've accounted for x1 and x2. So what we do is we'd estimate this. We'll a different color. So we'd estimate this model, we'd throw in this data or R or whatever you want to use and run a regression, and we'd have y hat equals beta hat 0 plus beta hat 1 x1 plus beta hat 2 x2 plus beta hat 3 x3. In terms of unbiasedness, the expectation of beta hat 0 is equal to the true value, and same with our x1 and x2, the partial effects of those. The expectation of beta hat 1 is going to be equal to the true value, and the expectation of beta hat 2 is going to be equal to the true ceteris paribus effect of x2. And now in terms of x3, the expected value, in expectation, our beta hat 3 is going to be equal to 0. So notice that including this x3 that has no effect on y is not affecting the unbiasedness at all of these other parameters that we're trying to find, or these other estimators we're using to learn something about these parameters. So overspecification has no, it's crazy H, no influence on unbiasedness. And we're going to see in a video or two, it does influence the variance of these estimators. So that's where it's going to cause a problem. In expectation, we're still getting the true value. So unbiasedness is not an issue when it comes to overspecification, but it is going to influence the variance of these estimators, right? And we want the variance to be as small as possible. So if including these x3s blows up the variance or makes it larger, that's going to be an issue.